Cool. Let's get started again. Yeah, we had already a very intense half of the morning, I think. So yeah, I don't have the intro slide. We just start with prototype version 1 or version 0 actually. And this is basically at a similar starting point, I think, what we heard yesterday, where you hear a lot of things. Some things are concrete, some things are vague. So you just put something out there, just to validate. Are we talking about the same things? And yeah, so this is one thing we built. Here in the boxes we have the entities. These have components embedded within them, and there is references from components to other entities in this case. And this already sparked huge discussions. Do you point from entities to entities? Do you point from components to components? Do you point from components to entities? Or potentially all of these? But what this is you can read along as well, actually. This is a JSON-like definition of. I don't know why this.
Tom can see.
Yeah, it's just you guys.
Yeah. Okay. Yep. So yeah, this is. Some people might have already seen this. This is a bunch of components. And it's actually very IFC 4-ish, It's it even has things like extrusions, I think, and axis geometry for the wall. So yeah, enough of this. It's really a full implementation, so you can read it. I just want to really get to what we learned from this. So I think one key lesson is these type relationships. So in this wall, we have two windows. And these two windows are really instances of the same thing. And that needs to be captured one way or another. For efficiency reasons, but also for the inherent semantics of that. That's what we do on the construction side. We assemble things and we need to know which things are the same. And to some extent, that collides a bit with this ECS definition. Because you want to actually eliminate indirections. You want to really have your components on your entities so that you can query these and not have additional indirections saying, hey, but this component is actually defined 10 entities over. So that collides a bit. I'll get to that later.
Sorry, you mean is a relationship? You mean is a relationship when you say type relationship?
Sorry, yeah, no, I mean the relationship that we call a type object in IFC. Okay. We also had long discussions, archetypes, typicals. Yeah. Type is so rooted in my head that I cannot get other words out of my mouth. But yeah, the relationship occurrence to something typical. There was also the beginning of something like ID prefixing. Because this is really a key point that lay on into that. Currently in IFC 4, you can hardly call it instantiate, because it's not the act of instantiating something where you define an occurrence. It's more like a bit of semantic metadata that says, this is an occurrence of that type. But once you instantiate something, you still have to tie all the ends together. So if you want that instantiation to be visible in your 3D view, it needs to have a representation. And that representation can, through all sorts of indirections, be related to something defined on that typical object. Yeah, but you still have to populate all the data. So, and what we're doing here is that not only once we say this occurrence has a typical relationship to a typical object, we're really carrying over all the components that it has transitively. But you still need to be able to reference those instantiated typical parts. In this case, we have a window that has a plate and 4 bars. And we want to be able to say, we want to be able to identify bar 1 on window 2. So it needs to have this concatenated name. That's what we kind of, very intuitively realized here. And also that in addition to a pure entity component system, we probably need to have an additional identifier that serves as a key in binding a component to an entity. For example, not just that it is a representation, but is this the body representation or the axis? Is this the external property set, or is this some other property set? So these are things we saw here, and that will come back later. And now, so the plan is, Tom, if you can show your 2 prototypes, I think so. That's the ECCG, the composition on entity component systems, and also as a second step, the schema language prototype. You kind of build on top of that.
So you can see this. Great. So we started doing some ECS prototypes, like Thomas was just saying, and we hit a problem with ECS where you have these indirections that we had to solve somehow. And what you get is you really have 2 options. Either you allow the indirections, so if you want to say that something is a typical of something else, you create a component that is a relationship, and you point to the typical, right? And then if you have many, indirect typicals, you have many relationships you have to follow, and then somehow you need to kind of agree on if a component is a component of the typical, then it's also a component of the instance or the occurrence. And that is not something that is really very vague or very ill-defined, but it's also not immediately obvious from the ECS. So one thing that might go wrong is if you do a query, you're looking for all entities with a certain component, you will find the typicals and not the occurrences, right? So what I tried to do here is just to write down that problem and to see how we can improve things. Well, I don't know where to go exactly to do a good job explaining this, but here you can see a general graph, like you have 2 occurrences, A and B, you have 2 types, type A and type B. These are type components, so there would be a relationship pointing to the type, and then the type itself, the typical, would be also an entity, and it would contain geometry and material. And now if you would query for geometry, or you would query for material, you would find the type, but not the occurrences, right? And so there's another way to do this. That is in this way, where you flatten it. You just say, okay, I have my entity A and B, and you have a geometry both for A and B specifically, and then you can query them and find A and B, but you lose the semantic information Thomas was talking about, that, these are the same geometries, but you don't really know anymore unless you go and inspect them. There's no real link between it. So yeah, the way to solve that is what I call a composition graph, but it's really way better explained just by calling it ID prefixing, is that there is a special relationship that is part of how you identify your occurrences. And the way to do that is that if you have a type relationship that is not part of the component, you say explicitly this is not a normal relationship, like you might have a voiding relationship, or some kind of a composition or a spatial structure or something like that. It's a special thing. It's on top of the ECS, and what it does really is to link occurrences to typicals and automatically creating a prefix out of that. So if C is the typical, so it's the type, then A and B as occurrences can be linked to that, and they will themselves create two new entities, A.C and B.C, and that is basically prefixing the occurrence to the typical, and thereby making it very explicit that you have basically a new entity, A.C and B.C, that has, let's say, information attached to it. This is what I called sub and virtual entities, but don't get hung up on that. I think the important thing to talk about is just ID prefixing. And it's basically the result of composing objects together. So this ID prefixing, it creates kind of a hierarchy. You have a bunch of objects that are in the hierarchy related in a parent-child situation. But the difference with a different hierarchy that you might know that, whenever you add something to a hierarchy, it's just a link. When you add something to this hierarchy, you make something new, you make a new occurrence. So that's what I'm saying here with the little box. When you add this specific composition relation from A to B, you actually create A dot B. So you make a new entity with the prefix, and that is then unique. And so what does this give you? Well, this new entity, it makes for some interesting new properties. You can make a relationship to this new entity. So even though it's just a prefix A dot B, you can make relationships to this newly created entity. You can also make new components on top of it. And this allows you to do a couple of cool things. So if I scroll down a bit, I explain this entire thing. If you have questions about this, please interrupt me, because it's all a bit ad hoc. I don't know if you can follow me. Yeah, if you make a query, it's cool. You can just say, well, if you make a query for a typical component, you can just follow the hierarchy of prefixes and return all of the leaves, and you will actually find all of your occurrences, even if you query for a component that is on the typical. If you want to do relationships, so you can actually do relationships to a specific component of a typical, but only for an occurrence. Or you can say, only for this occurrence am I gonna override this component for the typical, right? So your geometry might always be on the typical, but for one occurrence you wanna override it. You don't have to then insert the new geometry on the occurrence. You can actually override it on the typical. And that keeps all of your data in the same place and still allows for overrides. Same is true for defaults. Defaulting is just kind of the inverse of overriding. And here I go into a bit more, less A and B stuff, because that's more readable. You have a wall type, and a placement, wall and a wall type, fire rating, geometry. This is how you would build a little tree out of this. So the bold arrow is a normal component being placed on an entity, and the dashed arrow is kind of this, prefixing relationship. Then we talked a bit about archetypes. I'm not sure if that's still the way we want to go, but yeah. So this is kind of the idea of how we ended up with the ID prefixing. And then, of course, as these things go, I spent a whole bunch of time thinking about it, and then found out it already exists and was a solved problem in USD. Which is probably already something you heard from David earlier today, I believe. Is that correct, Thomas? Yeah, I see a yes. Yeah, okay. So yeah, this is a bit of the background of how really trying to fit ECS to our type of data created a bunch of problems that we then tried to solve like this, and then we found out USD was doing the same thing. So that's on the one hand, that's a bit of a disappointment. Spend a bunch of time looking at something, come to the same conclusion. But it's also very good, because it means that the solution we found works in real life, at least for some people, and that's really nice. Yeah, so I don't know how much time I have. I still have the other repository to talk about, but maybe first, are there any questions about everything I said so far? No, all good. Let me find the other one. Yes. Screen. Yep. Okay. So we talked a bit about that outcome and talked a lot about USD. So then kind of progressed in our understanding of the problem that we had to tackle. And then we were kind of, confronted with the question, well, what do we do then? Do we switch to USD, which is obviously a great solution to some people, but is it a good solution for us? So we talked a lot about that. Well, there are some downsides to USD. How big are those? We don't know, but we really need to know kind of also how much work would it be to start from scratch. And that is what I tried to do in this other repository. I tried to kind of explore the idea of, well, what if we would have to do kind of the things that USD does right, does well? What if we had to do those? We have to then invent our own schema language, our own way of storing an ECS, our own way of serializing it. There's a lot to it, but I wanted to just experiment and try to see what it could look like in theory. So I developed a little schema language that would guard, what is the data that is in your ECS, and that is this repository that you're looking at. So, yeah, this is, I don't know if this is a well-known IFC entity. It's a space boundary. But the nice thing is this is a schema, but it's just a little bit of JavaScript code. And it kind of defines what a space boundary is. So it has a space it relates to, it has a building element it relates to. And I think the space boundary is kind of, it is what it says. It's the boundary of a space and what is connected to it. I think it's used for energy calculations, these kind of things. So it has some relationships, and it has some basically, like, let's say, enum properties. So I described this little thing in a schema just to see how it would work. And the cool thing about having it like this is that you get a lot for free, right? So the first thing you get for free is you get syntax highlighting because it's just JavaScript. The second thing is you get auto-completion and these kind of things. And you can also do imports from relative files also for free. But the point was not really to do this in JavaScript. The point was to show how much effort it would be to do something like this ourselves. So that's kind of what this is supposed to examine. So this is the space boundary example. We can take that and generate code from that to be able to make a space boundary object according to the schema, a space boundary component specifically, right? So in JavaScript, it would look something like this. You have your boundary component and you fill it in with a bunch of stuff. But this is, again, completely autocomplete supported, and it's also compliant to the schema because the thing that is created here is generated from the schema. You can go a bit further, make an ECS, add a component to it. This is also something that Thomas said a bit earlier. So you attach to an entity, and you attach your component to an entity, but also specifically you attach it to a specific name and identifier, right? And that helps you solve problems like, okay, what if I want multiple components for an entity, or what if I want to link to a specific component? How do I identify that? Deleting a component or doing overrides is also important to have some kind of a name to it. These kind of problems are solved. And this is all live code. You can check out the repository and give it a go if you want. And then the prefixing looks like this. It's very simple. Let's say this is exactly the same hello wall thing picture that Thomas was just showing you. And this is where the prefixing comes in. So here I'm giving an example of how to override a specific component really deeply nested into a tree. So from the north wall, the left window, and then the frame of that window. So in this case, there's just one frame, but anyway, I want to make that red, and maybe the original one is green, right? So this is kind of the prefixing. It's written down in a JavaScript array, but you get the point. This prefixing allows me, together with this idea of virtual entities or ID prefixing with a hierarchy, it allows me to say that this window frame is red, even though it's a specific window frame. It's namely this one, the north wall left window window frame. So this one, right? So what does it look like if you then export this? Well, if you export it to something that looks like IFC 5, you would get a kind of a tree that looks like this. So you have a south wall with a green color. The sort of wall itself has a color. The left window also has a color, and the frame has a color, right? And then the south wall, it's the frame is colored green, then the right window is colored green, the north wall, though the left window is colored red because it's overridden. And so this is the serialization of the ECS, but it's really these operations that matter, right? So these operations, they kind of work to construct composable data in a hierarchy that is, let's say a superset of what you would normally call an ECS during game development. And it's quite powerful, and I like it a lot. So having a schema like this, it opens up more opportunities, like you can do validation, right? It's obvious stuff. Just to give you some context, for USD, these things are also possible, but then you have to imagine that there's already a solution out there, and it might fit for us, it might not. So it's good to kind of retrace the steps and see what it means to do it ourselves. If you look at USD, the big selling point and why it works in working together in big companies and with multiple authors and solving all of the problems that come with that, the concept of layers. So I'm assuming again that this is all clear now, and it's been explained by David. So it's the same thing, layers, but with an ECS. So it's all there in the code. You can create 2 layers or multiple, create a layered ECS out of that. And then it works like a normal ECS, but you can query it and it will respect the layers. So here I have some examples, like, if you have an object that is conflicted, so it's present in both layers but different, then the top layer will win. So I don't know if I really have the nicest example here, but this is a JSON dump of an example of a conflict. So this object would be conflicting, and you would really get just basically 2 objects out of this. And you could say, well, the lower layer thinks it's this, and the upper layer thinks it's that, right? So you have all the information to represent the conflict. And at the same time, if I scroll down a bit, you can also consolidate this information and just say, well, I have this conflicted object, but for you right now, I don't know, maybe you're using the API, you don't care about conflicts, you just want to know the result of all of the composed layers. Well, if I compose the layers, then this is the reference that you want, right? So some other layers might say something else, but this is what I care about. So what you're looking at here is not components, actually. This is the ID prefixing going on, but I think I skipped a couple of steps in my explanation. Basically, this is what I showed you a bunch of examples in the code for how to make components, but not for how to set up this ID prefixing hierarchy. I did show the images in the previous repository, but in this repository, you can also build that up. I kind of skipped that, but you get the point. Again, if you make a link with this ID prefixing between 2 objects, then one of them becomes the typical and the other one is the occurrence. Or, it's, well, potentially the occurrence if it's rooted. That's a different maybe a different discussion that Thomas will get into again, probably in a couple of slides. So what's the final thing I'm showing here? Well, it's just an example for how the conflicts can be respected. And you can still basically have the normal ECS way of working. So in a layered ECS, you don't really have to deviate from a normal ECS that much. You just have to say, this is the order of my layers, and then you can query the ECS like any normal ECS. You can ask it, what is the component of this entity, and it will return it. It will just respect the layers, right? You can ask it, how many components does this entity have? It will return it, respecting the layers. And then the layers allow you to do overrides and allow you to do different hierarchies, deleting entities, adding entities, whatever you want to make collaboration feasible. So you get, just like USD, you get conflictless collaboration, and everybody can have their own view of how the conflict resolving process is really going. So this is kind of the summary of what I did. Again, very ad hoc. I hope I was able to make sense. So thanks, Thomas, for allowing me the time to show it here. The end goal for me here, just as a closing statement, I would really like it if we can do something similar to this or similar to USD with the kind of incremental authorship. So like the diffing and transferring these small pieces of information. I work at BIM Collab. Really, model checking is for us is the big deal, and model checking your entire model again and again and again is just not very fun. So what I would like to end up with here is a system where we can at least define out of these building blocks that we're showing here, we can define diffs and like define these streams of edits and authorship coming from different people and somehow mixing them together. And for me, that was really the point where USD was an eye-opener, and I was very happy to hear from David and to see that you know, other people have done a good job thinking about this and working with it. Yeah, so thanks. Any questions about this? I'd be happy to hear. I can't really see the public, so please, Thomas, if you see some. No?
Well, I'll say it again. So we've seen two presentations, demos now. One was about EC or USD proper and about all the capabilities that has, and then we saw, I think, a parallel experiment with a working prototype that explores many of the same ideas. Have you gotten to a point where the team has a concrete recommendation, like we think we should, as our next step, try to do the same thing we just did purely in USD, or we think we should continue, an alternative would be, we think we should continue with our bespoke runtime and see how far we can take that? You guys have a sense of where you go
I think
next?
you're a bit ahead. We still have 2 other prototypes,
Okay.
and we're kind of building up towards that.
Okay.
But maybe Tom also has something he wants to add to that.
No, it's a very good answer, and it's exactly the question that we are asking ourselves in the past months. And as you can imagine, it's not easy to answer. So I'm looking forward to the slides of Thomas, which I haven't seen either, and I think it's just
very organized.
What a team.
Okay, thanks, Tom. I hope you have time to stay online.
You need to start screen sharing again.
Yeah. Thanks. So I'm doing a little bit of editorializing here because these are my lessons learned on Tom's great work. But I think what we see here is that this idea of composition, or the idea of an occurrence inheriting data from a typical element, has moved to a lower fundamental level. So it's now a bit of behavior on almost on the serialization, or on the library. And it's not just any other component like it was in version 1. And I think what we also especially saw in the subsequent work is that this is no longer just a bag of components, referring back to terminology that was introduced yesterday, but it's also a tree. So that once you have multiple layers coming in, whether these are incremental exchanges from the same author or supplementary exchanges from different authors, that tree allows you to correlate those 2 streams coming together so that you know, is something an addition or is something an override. So this universal tree, that's really a great enabler for composition, which is really an awesome use case for, that enables awesome use cases for end users that are currently with our express inherited serializations much more harder to realize. I think what we also began to see here, that classification only through components makes the data quite painful to work with. really just having naked entities that by themselves, yeah, aren't really much. That is really quite painful. If you have to scroll through your data set, there is, inherent indirections in figuring out what things are. And then the inclusion, of course, of layers, as I think Tom really framed that really nicely, is conflict-free multi-author data composition. Because before that, we were really more thinking, maybe in the Git way of thinking. You have chain stats or incremental diffs that allow you to compute from version 1 to version 2. But this idea of layers is really different. You overlay, and by definition, there are no conflicts. And then, this second point I think is a little bit too much.
You need to share the other screen.
Yeah, but I need to unplug and replug. We had the same thing yesterday.
Does it matter?
Depends if you want to make the people online happy or the people in the room happy.
Neither.
One of the things that just dawned on me is conflict-free means I don't see conflicts. Well, you can see them, but it's not the inherent point, right? And I'm wondering if that's a choice that you should make.
I think, you can definitely see them. As David said, as soon as you have multiple opinions, I really like that terminology that USD chooses there, you have opinions. If you have multiple opinions on an attribute within a prim, you see that. The question is more in software, how obvious do we make that for users? Is the default to just, blindly override, and users have to dig into all these, conflicting opinions themselves to have an opinion about that? Or do we have a much more, do we approach it from a different point of view and would say the default assumption is that you do have to explicitly choose or approve incoming overrides. But I wouldn't say that there is a fundamental problem.
I think the one of the alternatives is to think about, well, a system could be a proper way to check my work against somebody else's versus a layer. Right?
Well, one analogy that I think comes to mind is that currently we can just draw geometry, and then when two people draw geometry in the same place, we call it a clash. We have clash detection meetings, we have a clash detection list. This is a mechanism. You could build a data clash. You have geometry clashes and also data clashes. So your coordination meeting, it's like, hey, you said this, you said that, which is the right one, right? And I think one of the important things for a useful data exchange mechanism is you need to be able to express an incorrect model, right? You need to put something wrong in so you can talk about it. And I say wrong, I mean like unbuildable, right? You need to be able to express that and identify it and resolve it, because that's our work. That's like the actual work we do as designers and dealing with things, right? You want a contractor to be able to point in the data and say, hey, there's a problem here, raise an RFI. So I kind of think of this idea of these conflicts and stuff as like data clashes as opposed to geometry clashes.
Okay, but I think there are still some points we didn't touch upon. So we already heard ESD is in the process of becoming an ISO standard. But at this point, you can, well, in all honesty, hardly call it a standard. It is a software implementation. And if you want to understand specific bits about the behavior of that software implementation, it's almost like you have to reverse engineer that, looking at the code. So things are improving, but the yeah, the software implementation is the truth in that sense. There is not a spec or a standard that the software implementation is intended to adhere to. And this software implementation is huge. I still need to do some digging in where all these lines of code come from, but the order of magnitude of lines of code is really a bit scary. So, what prototype V4? Yeah, okay, and then maybe one other thing. There are 3 serialization formats. It's almost like IFC. There is a textual one, there is a binary one, and a zipped one, I think. And the textual one is nice and readable, but it is, not a well-known format. There aren't really parsers for that, except for the OpenUSD implementation. So what we did here in version 4, prototype 4, is what if we define a transformation of this textual USD format to JSON that, well, we all know what JSON looks like. It doesn't even really matter what flavor of JSON, what it looks like, but just something to get that bespoke serialization format out of the picture. And then step 2, what's the amount of effort required to, on top of that serialization from scratch, implement the subset of USD, the behavior, the composition behavior of USD that we're interested in. So that was a question that we wanted to answer. And yeah, well, I obviously, I'm the guy you call to implement prototypes. That's my core business basically. And in the end, it's not so bad. What I did is I built a 3ds viewer that can take a couple of these USD JSON layers. I should be careful calling this USD JSON because this has obviously nothing to do with USD yet. We brought up in the USD community this topic. How favorable are you of a JSON serialization? And well, they didn't get angry at us. So I think that's also a good sign. It seems to be something that could actually exist or become part of USD. It's also not something that's the OpenUSD toolkit has also been built in a way that so the serialization formats can be plugins. So this looks quite good. In the end, it was 100 lines of code to render USD JSON format. It was another 100 lines of code to do rudimentary composition of those. So what I did here in this version 4 prototype is I took an IFC model, I converted it to USD, I then converted it to USD JSON, and then I built my web-based viewer on top of that. Again, these 200 lines of code you're seeing now, and I wanted to test some basic composition here. So what I did is, you can see the change, but this is really the incremental kind of update going on here. Maybe. Well, I don't know if you trust me on this, but this second USD layer is just that wall that's changing with these 2 windows. And because of the fact that there is a normalized tree that is shared between these 2 exports, so to say, what is an override? The wall geometry changes, 1 window is moved. Those are overrides. And there is an additional new window. That's a new instantiation. Yeah, that just works. But a point from Leon, the incremental update here is also a valid model in itself. So you can also just look at that the wall with 2 windows, and that's just an equally valid model. And because of the composition, you can apply that to the pre-existing state. Lessons learned. Yeah.
Can you show the USB JSON? Does it show?
Yeah, we could do that. How much time is there?
Well, just 15 seconds. I don't mean the code for your viewer. Just the,
Yeah. So yeah, I think I was quite clear that this is not an attempt at defining a good idiomatic IFC5 representation in JSON. This is really noisy because this is like vanilla settings applied to the conversion output. But you can see the things that you're familiar with. So
You have an external screen, right? You need to drag it into your second screen
Can you duplicate the screen?
or mirror.
yeah, can I just do mirror? You secretly changed my settings.
Yeah.
Stop. Reshare. So you can see the terms that David introduced us to. There is DAF,
Can you go to
there
the
is the
top?
hierarchy.
Can you go to the top? Scroll to the top.
Yeah, that's a bit the noisy
Okay.
part. That's the USD styles for the surface colors. And it's a triangle mesh, and these are overlaid. So, but this is not a good. Yeah, we shouldn't be looking at this particular part. I think this is really saying that if we use USD without the OpenUSD toolkit, but with a more normalized standardization format, with the assumption that we're going to go all in on faceted, universally understood geometries, what's the effort required to implement a basic viewer with composition? And I think that looks quite favorable. There was nothing really prohibitive in terms of implementation that I would say this is a no-go. Yeah, so this is and then version 5. This is the tricky part. This is already what we had quite some discussions on, and this is, I guess, the biggest question we're going to receive.
Sorry, maybe ask a question there before. Did you maybe preface the reason for wanting a text format?
Sorry?
Do you give a reason for why you want to have a text format, not a binary or not a database? I mean, are we living in text world?
I, for the record, I didn't ask him to ask that question. It was all him by himself.
Yeah, I'm not surprised. Well, this day and age, if you have to choose the most universally understood serialization format, yeah, I would guess it's JSON. Could also be SQLite or something, but
Yeah, I guess the question is whether there's any legality or validation reasons for text. So, but, the only reason we want text is because we can read it. But at some point, text becomes pretty unreadable as well. Big files, complex relationships. So
It's also a prototype, so I mean, we can always see premature optimization to have you spend time designing a custom binary format. You're just trying to prove the point.
Yeah, I mean, everyone tends to forget, but I remember a session where we all agreed that it's definitely not going to be JSON, it's going to be something binary because that's absolutely necessary. But for now, in this prototyping stage, to be able to communicate with each other, we'll settle on JSON. But yeah, of course, we've been doing months now with JSON, and all of a sudden it became JSON, and we forgot about that original agreement that it needs to be binary. But at some point, we need to revisit that.
yeah, no, that's all good.
Yeah.
I do want to keep in mind, though, that there's a pretty strong workflow for IFC from the beginning of time, right? Which is that 200 years from now, someone wants to be able to open up a file and they can look at it, and they're not going to be able to do anything with binary, right? With a JSON, it's ugly, but it is text. So having the ability to have a human-readable file has always been a selling point for IFC. So that's just something to keep in mind.
Yeah, of course.
Okay. One last thing to conclude. So, yeah, we've been this. I think this has been a recurring theme. Throughout the day and maybe also yesterday. How big a step back is it if we're going to say, from now on, our main geometrical representation is triangle meshes, and I'm here to say that I think, and I've said this before in Zurich actually, but I guess also Passy, but not a lot of us were there at the point. I think if we can reverse the way of looking at geometry definitions, we can have the best of both worlds, where we now have this mindset of procedural geometry definitions, I don't know how to go about this, but they look like this.
We can see it.
This one. Yeah, and if I don't see anything. But if you're familiar with IFC, this is not a surprise, right? Because what this thing is a clipped representation of a wall, which means you have two Boolean results that have a left side and a right side operand, where they clip the wall in two parts. And the basis of that is an extrusion, which again has a basis as through a couple of indirections deep, you get to a polyline with some points. And I think, and this hasn't been very explicitly in the conversations today and yesterday, this is one of the core parts we want to get rid of. Because, I mean, this is a single element. But as soon as you have multiple elements, these graphs start to overlay. They start to hook into each other. A point on the polyline might actually be a point on the placement of another element. And you're no longer able to meaningfully make changes to models, because if you update your representation of the element, it might have all sorts of cascading
I have a
effects.
statement for that.
Sorry?
As you say, that's fine, but buildingSMART then has to explicitly say that design transfer is officially dead, right?
Hold on. I'm here to talk about this compromise that I see as a potential middle ground.
Yeah, and
Because-
just on that note, it's not up to buildingSMART to say it's that, and it was never up to buildingSMART to say it existed. This is a user-driven organization. Apparently someone made up a design transfer view that nobody actually wants to use in practice. So I think we should get more back to this user-facing requirements. If users want this, then it exists. So far, we haven't found any users that really want this.
There are plenty that want it, but my point is simply, and I think I was talking to Lex about this last night, there still needs to be, from buildingSMART, the owners of IFC, right? This is what IFC can do, this is what IFC can't do. Now, design transfer view is a loaded word, right?
Yeah.
And if we're saying, and you can then show, wait, don't worry about it, right? But if we're going to say, hey, we're going to make this, we're going to get rid of textures, right? Then somewhere someone has to say, IFC is not for render.
Yep.
Right? So that someone didn't say, hey, Autodesk, I can't render your IFC file. I say, well, IFC doesn't do that.
Yeah.
No, you just closed, right? No, it's not for render.
Yeah.
So,
Well, that's also something I want to react to. The reason why textures are so difficult in IFC is because we have 100 subtypes of representation item that through all sorts of procedural permutations result in some sort of form that most likely don't have sensible texture coordinates. But if we say, representations are triangle meshes, textures are also trivial. So maybe we shouldn't spend too much time on the texture as an example of what's inherently out of scope. But
I didn't care about it. That was just,
okay, but back to this idea. We already have this idea in IFC, right? And if you exchange a wall, what you, at least in the IFC 2x3 days, what you would get is you would get an extrusion and you would get an axis. And this axis provides additional context or information on how the geometry of this body representation, as we call it, can be interpreted into a more semantic or more, a richer view of looking at that geometry.
So I would just say personally, I totally agree meshes is a great place to start because it knocks out 80% of the complexity, right? So, but I don't think we have to close the door on the future on anything. I think, NURBS BREP geometry to me would be a subsequent step because you want to be able to receive geometry and process it, and if you have mesh artifacts, that's an issue, but let's just start with meshes, layer things on as we go.
Yeah,
It's not a prescription for the end of time. It's
Because
just the easiest way to start.
I think that's the correct word. When we need additional semantics on how you could interpret a triangle mesh as a procedural definition, then you layer those kind of geometrical semantics on top of that. So what is an extrusion? It is a base surface and directrix or a vector. These are two perfectly understood geometrical forms. But by encapsulating that in an entity definition, we're obscuring what we're trying to do. We can have these instead as top-level items next to that body representation, doing two things. So we no longer obscure our geometrical procedures with obscure entity definitions. I mean, everybody understands extruded area solid, but directrix derived, fixed reference, swept, there is a lot of permutations of sweeping a profile or multiple profiles over a directrix. And I think we can generalize that and break that down into well understood primitives that are currently supported in USD. And it's basically an extension of what we're doing with reference view. In reference view, we also made the choice. Instead of using Boolean operations, which are inherently, terrible because they depend on all sorts of implementation details that are impossible to standardize, like tolerance and fuzziness. We reverse it. We say, hey, I'm going to give you the end result plus supplementary information to reconstruct how we got there. And I'm advocating for, we can do that also for extrusions. We can also do that for the clipping planes. You know, these clipping planes are also just, well, polyhedral things in most cases. And we can do that for the void, what we're already doing. And all of these can sit side by side as top-level representations. So we also get away with this huge deep dependency graph that makes every exchange no longer predictable if you want to analyze the geometry in a semantic way, because you never know how many levels deep of Boolean operand you're going to get, or is your mesh an extrusion or not? You know, these kind of questions I think are solved in a more generic way. And this was my slide in Zurich, because you basically generalize and extend even, because my biggest enemy in the schema is this revolved area solid tapered. There are very few tools actually that support this, but this is saying I have a sweep, not along a directrix, but around an axis, rotating that around an axis. But in the process of sweeping, I'm also transitioning my profile, which probably makes sense in MEP kind of exchanges, but it's also not very flexible, because you only have a start and an end profile, and it's still not a mathematically understood surface. And this kind of surface doesn't really exist in a BREP modeling engine. And it's the same with alignment curves. These are also or alignment sweeps. In the end, we're all creating permutations of sweeping a profile along a directrix. So why not make that more explicit? And then these are also, because they become top-level representations side by side, that you could even build a viewer that just shows them. And I think that's very informative for end users. Okay, something else. I've been repeating myself enough. This question came up with from ODA. I don't know if it was Sergey or Neil, but so how do we see? We've been talking about ECS for not a decade, but quite some time, and now we're talking about USD. What's up with that? I think that USD's view on how you define data is a pretty sensible extension of how we could apply ECS. It's kind of taking the lessons learned that I had hoped to have you been able to follow along. You know, that a tree is really nice, so that you can compose multiple data sets and fold them together in a sensible way. But also, in addition to just having these naked entities, it's quite nice to make what they really are a little bit more special. Also because it allows you to constrain the type of components you could apply to an entity. I mean, if you really leave everything open, how are you making sure that you're not going to apply materials to your property set or these kind of bizarre constructions? If you have one specific kind of label that has a very rudimentary categorization of what something is, I'm not saying that has to be IFC wall like we have now, but it could be something like physical product, property set, or a broad categorization of what role does an entity fulfill in an exchange. I think it's a nice extension to ensure more the data integrity. And then the third aspect is this was skipped over by David, but there is also additional constraints you can impose on how a component or API schema is related to an entity or a print spec. Can you apply it once? Can you apply it multiple times? or can you only use it as a lens to look on your data? So I think it really quite nicely aligns with the lessons learned. Okay, I have like a wall of text for 4 slides. If there is any questions, I think we should do that. Otherwise, I'm going to meander around all sorts of observations that I've had over the months. Yes.
So maybe quickly, yesterday we showed that the existing, I'm going to say IFC business logic model as opposed to schema, but it's basically schema can be represented as a set of components. Right? It looks like the example you showed, you did something similar. So what's your gut? I mean, I've been talking about like team strip it down versus team burn it down. I mean, can we evolve the IFC business model to, in your experience, toward a USD framework, or do we have to like burn it down and start over? I mean, do you think that this is evolvable?
I think so.
I mean, that's a dangerous answer to give, right? I mean,
Why?
I think there is a lot of immensely valuable thought embedded in the IFC schema as we have it now.
Right.
But that doesn't mean that constructs that we currently have need to be copied over verbatim.
Right, and in fact, they could be transformed into this, but your experience and our experience shows this is doable, right? We don't have to start by burning it down and starting with a USD thing. We can look
I think it's good to take a step back from the IFC schema and look at the mechanisms. What do we have? We have a set of built element labels. We have this idea of property sets. We have materials. None of these things are perfect, but what are the mechanisms that are valuable, and how do they map to a more sane, modern structure?
On slide 20, I think one of the reasons we looked at a component system is buildingSMART is not a good authority on how data should be assembled. And so the idea that we do a lot of work to make sure we can enforce it. There's places that need to be enforced, I understand. Illogical is different than breaking, right? So we have to understand how to evaluate geometry, but if we're, like your example, the property set, material on a property set, it's illogical, but is it that we should validate components and not how you put them together? And that's a better role for buildingSMART, because every place in the world wants to describe data differently.
Well, I think that's also why I said that what USD calls is a schema. We should really not go too deep down in the taxonomy we have now. We're not going to forbid that because that's a problem, right? We made very bespoke associations between certain property sets and certain building elements, and constantly need to revisit that, and it's intractable. So yeah, that really needs to be only the top 3 or 4 levels, where you really go from things like where you differentiate between things like a process or an element. So you're not going to associate, and well, I'm repeating myself, but I think if we stick to the taxonomy we have, but limit it to the first 4 levels or something, is it naive to think that it's somewhat universal?
Yes, I think so.
Yeah, I it's a question.
I mean, the Zurich meeting, we heard from the team that they classify they have an invented name for components that they use walls as the infrastructure group in Zurich, right? They throw away the classification of a wall, they use the concept, and they associate the properties to it. I can't remember the group that presented, But they're basically saying, well, these are nice foundational components, but I think of them my way. And that was, I mean, I think that exists everywhere.
I think it's a different discussion. I mean, if you don't want to use IFC, then don't use IFC. Or, I mean, there's no ways forcing it. So this will always happen, no matter how many concepts we have in IFC or outside. People will always make up their own terms. That's fine.
Okay.
Okay, yeah, a couple of questions. Like, I don't know if in these demos or in USD in general, how can you separate if you have like a USD with several, say you have the architectural model, structural model, and MEP, and you can I just open the MEP like part of it? Okay, you can do it.
Yeah, I think that's the core idea. This is that you retain ownership of your opinions. The default way of working is that you don't mix layers as they exist on the file on the file system. You compose, you overlay them, but that act of overlaying is, what was it? Non-destructive, right? That's the term they use. So it's a view on a composed set of files, but those files remain there, and you could.
So is it several files then, or is it like is the USD like several files, or is it like one file, or is it?
I'll give an example after.
Okay.
But yes, it's several files.
Okay, yeah. So also the increments, that's like also like a one file.
Yeah.
Okay.
So just some random observations then. So the schema language is also USD. So what we currently have is, we constantly mess up. So we have corrigenda and addenda, and nobody knows the difference. But and these currently come in as completely independent new schemas because of reasons. And well, in USD we can also layer schemas and get a composed view of schemas. So we can. I think that's really nice.
How are they defined? How are USB schemas defined?
There's a particular that you have to create a USD
So
layer.
what is the like? Is it like JSON schema or its own?
No, it's
thing?
USD.
Okay.
Its own,
Its own bespoke schema definition.
When you have to run a script which generates a C++ class which gets loaded into the runtime, which checks it.
You don't have to.
Well,
There is, yeah, you can do
That's
that.
the standard way.
Yeah, and there's an option to skip the C++ and
So I'm not saying this is particularly pretty, this schema language. But this is roughly what it looks like.
Is this USD schema, or is this something that you done?
This is the current USD schema language as a
this is a
USD file.
schema that Thomas wrote
Okay.
in USD.
Okay. But this is not JSON's. I mean, is there a conversion from this to JSON schema, or?
At this point, no. Well, for my reinterpretation as USD as JSON was only the which would apply to the schema language as well. Then, but
Yeah, I think you should think of IFC5 as IFC5. So we're going to define some kind of a schema, probably need something more than just JSON schema. So imagine IFC5 will be JSON, there will be a JSON schema defining what you can do with IFC5. I think we need something more. We will define an API for IFC5. But the nice thing is that as soon as you import an IFC5 JSON into USD, there's an import plugin for JSON, and there's like this plugin to make USD understand IFC5. And that was what Hans was showing. So it's not like we're going to define IFC5 using USD schema language. It's more like, thanks to this very flexible USD schema language, USD can very easily read IFC5 files. So that's a reason for a lot of people that are now in the Omniverse or whatever, that to easily take in IFC data and link it to digital twins and do rendering and textures, etc., etc. So this is more like an easy way to get IFC into other domains instead of define IFC with USD. That's not the intent.